Hello.
Hi, Serena.
Hi, Stan. Hi, nice to see you here today. I thought we'd just kick off because when we were having a little pre-chat, you described self-driving vehicles and the development of them as the mother of all problems. Where did that come from? What do you mean by that?
So I think the systems that we're putting into automated vehicles are made up of many, many different sorts of sensors, software components, so themselves extremely complicated systems, and every part of that system is prone to some sort of error. And then we're going to drop this complicated error-prone system into this extremely complex thing called the environment, in which some of the actions in that environment could be completely unpredictable, and that they're incredibly difficult to model accurately and precisely. And then we're going to use that system in a safety critical application where human life's at risk. And so you can imagine, if you look at just a simple case of automated driving, like highway driving, in which you might want to be able to drive at 130 kilometers per hour on a highway, you parameterize that environment and you come up with something like 10 to the power of 31 different scenarios that you really want to expose your system to be sure it's safe. And so the universe has only been alive for 10 to the 17 seconds. So 10 to the 31 scenarios seems like rather a lot of scenarios to test again. So you can see that's why it's the mother of all problems, really.
You've had some success with this, considerable success, whilst, with Five. Between 2017 and 2019, you developed, tested and demonstrated self-driving system and self-driving vehicles on the streets of London. But since then, the sort of pace of it appears to have slowed a bit. What have been the stumbling blocks, and when are we likely to really see self-driving vehicles on the road on a regular basis?
Yeah, so in that period of time, we built a team of about 140 people, and we built a prototype automated driving system. And what we discovered is it's actually quite feasible to build a system that most of the time will drive safely in a complex environment. We put it into a 20-kilometer round trip in South London, and we took hundreds of people out on these test drives, and most of the time the safety driver didn't need to intervene. So that kind of proves that it's kind of feasible to build a system that works most of the time. But the problem with automated driving is it's a long tail problem. There's a very, very long tail that goes on basically to infinity of possible things that might happen in the world. And I guess we discovered in that process that the real challenge was, how do we tame the kind of long tail, really? And so we set about building a workflow and a simulation environment which would allow us to develop and to test systems. And really for the last year and a half, that's pretty much what the team's been doing, is building a very sophisticated simulation and workflow that will allow us and others to develop and test automated driving, basically to expose the system to plausible scenarios that will find the vulnerabilities in the system and allow us to trace them and fix them.
In that process of development, how has the way that you define what self-driving means effectively, has that evolved, that definition?
Yeah, I think it's evolved for the whole industry, actually. Not just in the last couple of years, but I think over the course of the last 15 years, really. So it's probably the whole term of self-driving probably goes back to 2004 and the sort of DARPA Grand Challenge in 2004, and I think peak hype was probably 2016 when Gartner put it right at the top of the hype cycle. Since then, we don't often talk about self-driving anymore. We tend to talk about automated driving, and there's a subtle shift in that discussion then. So we're now including cases where the vehicle is driving, and we're actually including cases where the driver is kind of expected to be in the loop, actually. And that's one of the things that I think has happened since we hit peak hype. We've been through the trough of disillusionment in 2020, and now we're into the kind of slope of enlightenment. And the slope of enlightenment really means that we can start to see crystallizing in front of us real, tangible, feasible opportunities to put automated driving into real practice. And some of those are in things like passenger cars, where we're going beyond a driving assistance feature to a feature that in a very tiny operational design domain might be driving on a particular autobahn network in Germany. You are able to switch this system on and the vehicle will safely drive, and you can take your eyes off the road and your hands off the wheel, and you're not expected to. So that's a very tiny operational design domain. So that would be a good example of things that have really come into focus as feasible, valuable things that the industry wants and people are willing to pay for, and then all the way up to drive anywhere robo-taxi services that people like Waymo and Cruise are investing heavily in San Francisco or Pittsburgh or Phoenix, Arizona.
How have you sort of tackled the challenge of bringing two quite disparate worlds together in the sense of the tech companies and the automotive companies, and bring them together to work on this project, which obviously, as you've said, has got huge costs attached to it?
Yeah, I think it's a really important point in terms of how actually are we going to solve this problem. And I think the first phase of automated driving has really, the leaders have been the tech companies. So it is US companies that have raised significant amounts of capital that have applied cloud software development ability, machine learning skills to try to apply computer science to solving the problem of automated driving. And the things that they need to become now, they've got to become automotive companies, because the automotive sector absolutely understands safety criticality and understands how to specify requirements, functions, build to a high coding standard, verify it, validate the requirements, and ensure that in a traditional V-curve that you can build a kind of safe system. So the automotive industry has well-developed practices, the ASPICE practices for building automated driving, and the tech companies are all desperately trying to become automotive companies. The automotive companies, on the other hand, have all these skills that are able to develop stuff at a unit level, and actually what they're now presented with is a very complex system problem, which requires cloud skills and machine learning skills. So they're desperately trying to become software companies. So these two worlds are each trying to look like the other. And in fact, I mean, obviously the answer is both those worlds have to come together. So we have to find a way, which I think we are finding, in which technology companies and automotive companies figure out how they collaborate and add value to each other. And that can be contractual between companies, or it could be vertical integration between them, and it could be either, really.
I mean, where are we now in terms of the safety of the current generation of automotive vehicles? Because obviously there were quite a lot of headlines about Tesla's autopilot system, crashes, and obviously the news and the media do jump on the bad news stories, but what's the current reality?
Well, I think if you look at the automotive sector and look at individual features that they're producing, if you buy a vehicle with adaptive cruise control or something on it, I mean, it's going to be pretty solid actually, but it is tuned to a point where it will tolerate certain false negatives. So it will withstand the ability to not see something because you as a driver are in the loop, but it won't. But it is tuned not to accept false positives. You don't want the brakes slamming on while you're doing 70 miles an hour down the motorway. So it's possible to build systems like that that are absolutely concrete, rock-solid systems, but they're actually solving a different problem. When it comes to taking the driver out of the loop completely, where the system has to be able to tolerate all cases to a safety critical standard, that is very much a kind of work in progress for the industry. So we already see it in the States now. So if you look at Waymo, for example, has a significant deployment of automated vehicles in Phoenix, Arizona. So Phoenix, Arizona is it's a sunbelt city. It never rains. The streets are wide open. You can probably see like 8 GNSS satellites at any point in time, and there's often a following car which is able to sort of keep an eye on the automated vehicle. So it's a very, very contained operational design. But we are already seeing that, and the same is true of Motional in Las Vegas. We're seeing similar trials of Cruise in San Francisco and Argo in Pittsburgh and so on. So we are seeing those actually come to life, but very, very tiny operational design domains. So I think we're going to see both both things happen. The automotive industry is going to build increasingly sophisticated driver assistance features. So the first of those that is truly automated, hands off the wheel, eyes off the road, is called automatic lane keeping system. So you can switch it on, and up to a certain speed, the vehicle will automatically drive without you being responsible. So that's already coming to market now. And I think these operational design domains that are currently quite tiny are going to kind of expand out from the US. So we're going to see both kind of encroaching on each other, I think, over the next several years.
And are there any trials like that in Europe, or is it just focused on the US right now?
Well, Europe is a really interesting place, actually, because it looks from the outside as though all the activities happening in the US and all the activities happening in China, and that's certainly true in terms of headline numbers and large amounts of dollar investment going into companies. But I think if you actually look at the number of people in Europe working on automated driving, they're a little bit more hidden, actually, because there's fewer big startups in Europe, and we're one of the biggest startups in Europe, and we're still relatively small. But you look in the automotive companies, and the large German or French automotive companies, or the tier one suppliers to them, have thousands of people working on different aspects of automated driving. So in terms of number of engineers working on automated driving, Europe is probably at a similar level to the US and China. It's just configured differently, and that's kind of a hidden thing, actually, that it's just configured differently here. But I think we're going to see similar breakthroughs here, just in a kind of different form, actually, is what we're going to see.
One thing you mentioned earlier, which I thought would be good to sort of draw you out on a bit, and I think it probably applies to your industry, but across the board. You mentioned that you fell into like the trough of disillusionment, great phrase. How do you get yourself out of the trough of disillusionment? How do you build it back?
I think the industry fell into it, and any company that like we did, actually, raising capital at the peak, is going to discover that the original vision and dream that you have in terms of how the thing will develop, you realize that actually this is a much bigger problem than we thought, and we actually need to go and back and build very substantial infrastructure if we're really going to crack the problem, really. So that realization changed what we were doing as a company. So we still maintain a small automated driving system team that's building kind of prototype systems, but the majority of our company is now working on building scalable cloud systems for creating simulated environments, for creating models, and also the technology that allows us to take data off vehicles, accurately annotate it, turn it into scenarios that are encoded in an industry standard format, and do all that with a degree of formality that allows us to scope out and define the whole size of the problem, and then start to explore it and measure the results objectively. So we've been building that infrastructure is absolutely essential to crack this problem, really. And I think that realization through the falling knife phase, if you like, then allows you to sort of figure out, okay, where are we going to play in this firmament of what's going to be needed, and find our slot. So we've been quite successful in building a product that works incredibly well, that is now scaling very significantly, and we've got that adopted now by both startup companies and also by significant automotive vendors at the same time. So it's been for us a very, very interesting sort of phase as we've sort of maneuvered ourselves to look like that. And I think everybody in that sort of phase has been doing the same thing, either figuring out the niche that they're going to get into and play in that and raise capital against that, or they figured out how they can play a part in providing some utility that's required across the industry.
Looking to the future, and obviously the other big event going on this week is COP26 in Glasgow. What role will automated vehicles hopefully play in helping us build a more sustainable future?
Well, I think huge. I mean, there's two big things going on in mobile right now. One is electric or zero carbon solutions of one form or another, and the second is automation. They are very, very tightly linked in my view. So they've both got a separate cadence. The value of automated driving is that it will allow us, I think, to significantly reduce the number of vehicles that might be required for any kind of purpose in any kind of conurbation. So rather than one vehicle or two vehicles per family, you can easily show that for a city, if you set particular wait times to be even quite low, and you have people that are able to kind of share transport as if you look at people transport, you can take the number of vehicles in a city down by about a factor of 10. So the impact that has on our use of resources on the planet, the impact of all those, obviously they were all going to be electric vehicles to begin with. I think it can be very, very dramatic actually. So the investment that we can make in automated vehicles, I think can be a massive lever to change quite significantly the way our cities work. And of course it also changes where people live really, because once you've got an automated transport system, people I think are going to be much more likely to migrate to the kind of outskirts of a city because it's now possible to get around that city. So I think it will be quite dramatic, the impact.
What sort of timeline would you roughly put on that?
Well, we're going to see, we're going to see, if you just take Europe for example, I think we will see in the beginning of the second half of this decade, so 26, 27, 28, you will start to see automation come in for things like logistics applications first, because they can go rather slowly and rather safely in things like residential areas. So I think we will see that happen, as well as obviously automated trucking on highways. So those are the two obvious applications there that we're going to see first. I think it's going to take a little bit longer to get to drive anywhere passenger vehicles, typically because there are other factors at stake in terms of the safety of a vehicle which carries people, but mostly because those vehicles are going to have to travel in different operational design domains at higher speeds, and therefore the problem is made significantly simpler if the vehicles can go slowly, and conversely it gets significantly more complicated if they've got to go more quickly. So I think we're going to see a phased approach where we'll see some applications come in 26, 27, 28 in Europe in logistics. Then we're going to see passenger probably around the end of the decade. We'll start to see that get deployed. I mean, it could probably be done quicker, but of that order.
I mean, and another sort of more practical shift that people always kind of either joke about or refer to when they think about autonomous vehicles. Personally, I've been struggling to pass my driving test over the last few years. Will driving tests become a thing of the past, or will there be a sort of hybrid model? If you're sitting in the driver's seat of an automated vehicle, will you still need to know, have road awareness?
Yeah, I think I've just lost my mic actually. No, it's back again. I think, I think people are still going to want to drive. Frankly, I mean, you should definitely learn to drive, because driving is actually quite good fun. And I'm currently looking at a very nice car that I was thinking of buying actually. So I think people will still drive for fun actually. So you will still see that. But I mean, we are already in cities. We're at the point where people typically don't buy a car and they use public transport of one sort or another. And I think that's just going to become much more prevalent, I think, once we've got automation. So it won't actually be necessary to learn to drive, but I still think you will see people want to do that really. So.
And obviously in your career, Stan, you've got an admirable track record of funding and selling billion-dollar companies, 3 so far. Is that the future for Five? Is that your ambition for it as well, for it to become a billion-dollar company?
Well, you can never be entirely certain what the outturn of a business is going to be at any point, really. But yeah, we're certainly very happy with the journey that we've been on and the progress we're making with the product we have. Our product is awesome. And we show it to people and say, wow, that is amazing, how can I use it? So we really like that kind of feedback actually. So I'm confident that we're going to be able to scale a business using that by partnering very, very cleverly with particularly automotive companies to kind of help them put these two technologies together so we can finally crack the problem. And whether we do that and we take the company public long term as a multi-billion-dollar exit, or whether we end up in a different kind of partnership with somebody, we'll find out as we progress, I think. But yeah, we're certainly going to end up building something that I think is going to be key to cracking the problem of automated driving.
Fantastic. And did you find that the pandemic threw up any obstacles towards your company and development? Obviously, remote working might not be such a problem for you in your line of work.
Yeah, I mean, a few hiccups, obviously, because that we're not able to, when we're building an automated driving system itself, we are obviously putting individuals like an engineer and a safety driver in a small vehicle in proving grounds and on public roads, and we weren't able to do that for some time. So there was a sort of gap when we just didn't want to do that really. But I think actually what it's sort of done is emphasize what we knew already really, which is that the vast majority of the development and testing of these automated vehicles has to happen in simulation anyway. And that we were already building a system to do that, so it didn't actually slow our progress down. In fact, if anything, it accelerated the speed in which we had to use our own technology ourselves really. So that if anything actually helped us, I think, become much more effective during the pandemic. So and I mean, if you just look at the market leader in automated driving, Waymo, they've done. I mean, it's a terrible measure actually, but they claim they've done like 20 billion miles of automated driving, and they've done 20 million miles of physical driving. So it's 1,000 to 1 ratio of simulated driving versus real world driving. So obviously what's probably more important is how eventful is that driving, and how many scenarios and so on, and how are they measuring the outputs of that. So that really defines how complex it is. But by the time we get to the middle of this decade, the world is going to be doing something like 500 billion scenarios in simulation every single year. So that's going to give rise to a vast amount of compute requirements and a vast amount of data to mine and to build into safety cases to prove the safety of these systems. So it's a huge field, and the pandemic sort of caused us to accelerate how we built that, and we started to use it a lot more ourselves.
And I suppose one question that your average person average driver might have is the affordability issue of automated vehicles. I mean, how is the industry going to tackle that? Is that a case of government subsidies? What are the solutions that are being discussed?
Well, again, it depends which end of the spectrum you come from. In the automotive sector, you can already see that people will pay a premium for autopilot in buying a Tesla system. So people are willing to pay several $1,000s for a feature that they can switch on and might allow them to have the car drive itself in an automated way. So that's sort of fairly straightforward, I think. I think when it comes to fleets of shared usage for moving goods around or moving people around, I think the models can be shown to be quite economically effective versus the cost of humans driving them around. So in logistics, I mean, it's quite easy to show that you can slice about 40% of the cost of delivering something by using an automated vehicle, and similar kind of savings of shared use of fleets of automated people transport. So I think it's going to be economically powerful. It's going to be environmentally helpful. And it's going to, once we get there, it will kind of unlock a multi-trillion-dollar industry for us all. So really interesting space.
I mean, that does sound very exciting. And I guess, as a sort of last point, really, like, how will the industry deal with conquering the fear factor, I suppose? Because there is still some fear associated with the idea of getting in a car and the car doing the work and making sure that the AI running the car is as intelligent, as a human, basically. And that's a sort of cultural and societal shift, I think.
Yeah, I think it's a big responsibility on the industry to develop and test its systems with high rigor and high formality that allows us to sort of build an argument-based safety case at the top of which is the system is safe, and we have to prove that with evidence to our own satisfaction and also the satisfaction of regulators. And I think that we'll be doing significantly more testing than the average consumer would ever expect us to be doing, really. So I think it will be pretty safe and solid, as a system when we finally get to deployment. So that's a job for regulators to make sure that is the case. But I think actually the human reaction we saw on taking people out on an automated driving is that the first few minutes they're saying, wow, I'm not sure about this, and will it take this roundabout safely? But after a few minutes, they'd forgotten the car was self-driving, and you find that with like Tesla Autopilot. We've heard stories of people switching on, then doing their email on their phone while the car's which I personally wouldn't do, by the way. I think humans are probably quite likely to trust it sooner than they probably should, actually. Yeah.
How long till we see automated vehicles on Top Gear, do you think?
I don't know, but I'm not sure Top Gear are going to like it, actually. I mean, we're going to see features increasingly, paid for features increasingly shown on Top Gear, I think. Hopefully showing it in a good light in the second half of this decade, I think, is when we're going to see it. Yeah. So.
Second half of this decade.
Yeah.
Okay, well, Stan, thank you very, very much. That was a fascinating conversation, and I feel like I've learnt a lot, and I hope the audience have too.
Yeah, thanks, Serena.
Thanks.
Thank you.